Hello, everyone, and welcome to our finals. Okay, so we are now in the final stretch of our course, Electromagnetism lecture. Okay, so for our first module for finals, we have electromagnetic induction and inductance. Okay, so what is this electromagnetic induction is all about? Okay, so allow me to share with you my screen as we are going to discuss today module 7. Okay, so checking again if my microphone is on and I am recording. All right, everything seems perfect. Okay, so I believe you are now on my screen. Okay, so this is what electromagnetic induction is. So, okay, so to begin with, okay, so when a magnet and a wire move relative to each other, a voltage is induced. Okay, so we had talked about the charging that we had previously discussed during the prelim. Okay, so there we also discuss induction with that charging through induction. Okay, so when we say induce, it is being somewhat forced. All right, so um how will this proceed? Okay, naturally. Okay, so the amount of voltage that is being produced depends on the three factors, which are the speed, the magnetism, and of course the shape of the wire. Okay, so the higher the speeds, the higher voltage it induces. The stronger the magnets, the higher the voltages it produces. Okay, and the more wires or the more coils there will be in the wire, the higher the voltages it will produce. Okay, so if we have our in-person classes, we should have done this in our laboratory, wherein we have our magnet, we have our wires. Okay, we have our compass in order to learn the direction of our electricity. Okay, however, we don't have our in-person classes, so you have your virtual laboratories, by the way. Okay, so you can also do this at home if you are that really curious on what we are talking about. Okay, so this is the wire. These are the coils around the magnet. Okay, so the more coils there will be, the higher the voltages it will produce. Okay, so and your magnet, you can have it go in out in that direction. Okay, and the direction of the magnet will also depend on the direction of the electricity that is being produced. Okay, so with that, electromagnetic induction again is inducing voltage by changing the magnetic field around the conductor. Okay, so any change in the magnetic field will induce a voltage. So an example of an application with this would be the traffic control signals. Okay, so with this, the Faraday's law is being applied. Okay, in your laboratory, you have your virtual lab for Faraday's law. Okay, so the induced voltage in a coil is proportional to the number of loops multiplied by the magnetic field changes within those loops. Okay, so and so on and so forth. You may read this PowerPoint presentation. I am also attaching this in your module. Okay, so talking about electromagnetic induction, we are making use of generators. Okay, so we already know that generators make use of a motor, and that motor converts electrical energy, okay, into mechanical energy. All right, so but a generator in reverse converts mechanical energy into electrical energy. Okay, so there is a difference of the motor and the generator, by the way. Okay, so generators and alternating current, you have your mechanical output. Okay, the mechanical energy is being converted into electrical energy by the use of generators. So you have your motor, you turn your motor in the rotating loop. Of course, there is a magnet, all right, and turning that mechanical energy into electrical energy. So to produce a current in a coil of a wire with a magnet, what must occur? Okay, that will be our question. And what type of current will this produce? I believe you can answer that question by now. Okay, so mechanical energy is used, okay, in order to produce electrical energy by generators, and alternating current is being produced. Okay, so in Maria Cristina Falls, they have their turbines there underneath the waterfalls, okay, the cascading water. Here we go again. Okay. So the cascading waterfalls of the Maria Cristina Falls turn the turbines underneath in the waters because of the very strong currents. All right. So your generator there converts that mechanical energy. You have your magnet and then your conductors, okay, so that will be converted into electrical energy. Okay, so explain what the difference is between a generator and a motor in terms of energy. We already mentioned that earlier. A generator converts mechanical energy to electrical energy, but the motor is vice versa. A motor converts electrical energy into mechanical energy. So just like our appliances at home, we are making use of the electricity in order to to help us. So say for example, a lawn mower, okay? A lawn mower, you use the battery or the electricity, and it will aid us in cutting our grass. So from electrical energy, it is being converted into mechanical energy. So that is a motor. Okay, so transformers, this one, okay. We have primary coil and secondary coil for transformers. Okay, so the primary coil connected to a voltage source, and the secondary is connected to a galvanometer. Okay, so when the voltage source is turned on, current briefly surges through the secondary coil. Okay, and the voltage when the voltage source is turned off, the current briefly surges through the secondary coil in the opposite direction. So the magnetic field building around the primary extends to the secondary. Okay, so these transformers have different types. Okay, so we are using this, of course. Okay, the National Power Corporation is there still Napocor, okay, or Mualsi. Okay, in Misamis Occidental we have Mualsi. We have transformers. Okay, so the transformer could be step up or step down. Okay, so um because these are used to step voltages up or down. Okay, so when we say step up, okay, the voltages will be from lower to higher. And when we say step down, the voltages will be from higher to lower. So from our primary source of power, there in Mindanao is the Maria Cristina Falls. So from there, the voltage is very high. Okay, so in our homes, we only use small voltages. Okay, so from Maria Cristina Falls, we make use of transformers, the step down transformers, in order to use the current into our homes. Okay, so we have our induction of electric field by Faraday, an induction of magnetic field, and that is from Maxwell. Okay, so for this, for Maxwell, the induction of magnetic fields, okay, we have our electromagnetic waves, and that would be for our next module next week. Okay, so that is all about electromagnetic induction. And for your module, what you're going to do, okay, we are on module 7, and this is due on May 15. Okay, after May 15, no more submission of module. Okay, so all modules have been posted 2 to 3 weeks. So why is this so? Okay, so I think I have to fix this one, but if you are going to click download, it will work. Okay, so I guess just download the the Word file. Okay, so because you cannot see it through Canvas, so you may just download this one. Okay, so here it is for our module 7. You have your tasks here. Okay, so these are only very simple tasks, and you have your process questions after each activity. You have the YouTube videos, and you have your questions, the process questions, and the discussion. So just answer the process questions and the discussions from the YouTube videos that you had watched. Okay, so we also have the Lenz's law, okay, for electromagnetic induction, as well as, of course, the Faraday's law. So just answer the process questions, and when you submit, do not submit the entire module, just submit the answers directly. Okay, so once again, this module is due on May 15, and if you cannot take a preview of our Word file for this one, just directly download your file, and it will you can have your file right away. Okay, so thank you very much for watching, and do your work in advance, because I will not be entertaining emails regarding with your work 48 hours before the deadline. Okay, so work now, start working now, so that you will not be late in your submissions.